Hey guys, so far this week we've learned about different types of heat energy transfer. We've learned about thermal conduction, we've learned about convection, and we've learned about radiation. And we've also learned about specific heat. So specific heat is the amount of energy it takes to heat 1 gram of substance by 1 degree Celsius. Okay, so if you this doesn't just apply to a single gram of a substance. This can apply to a whole substance as well. You know, a whole substance can be composed of many grams, and that heat travels through that substance gram by gram. All the specific heat statement is saying is that for one portion of that substance, it takes a certain amount of energy to heat it by 1 degree Celsius. Okay, so a substance that has a higher specific heat takes longer to heat. It takes it longer for its temperature to increase by 1 degree Celsius. If its specific heat is a lower number, then it takes that object less time for its temperature to increase by 1 degree Celsius. Okay? So let's take a look at this live in an example. So over here I have a pot of water that's nearly boiling. The water's really hot in there, and it's starting to bubble, it's starting to boil. And if I put a metal spoon in there, so I'm putting the metal spoon in there, I'm going to let it sit in there for a little bit. I'm going to keep my finger on it for a little bit too. All right. So I have this spoon in here, and I have my finger over towards the side of the pot where the steam's not really hitting it. So I don't really feel any heat at all from the air, but more specifically what I want to focus on is the heat that is starting to build up in this spoon where I'm holding on to it, okay? So through thermal conduction, the heat is being transferred from the water to the spoon, and the heat is traveling up the spoon to my fingers, and I can feel it heating up right now, okay? And as I leave this spoon in the water longer and longer, it's going to get hotter and hotter, and it's going to get harder to hold. Okay? In fact, it's hot enough right now to let go of. I'm going to let it go because it's pretty hot. Okay? So I turned the stove off. I'm going to let the boil come down now. But what I wanted to show you by this is if I had a wooden spoon that was the exact same mass as this metal spoon, well, that wooden spoon would not heat up as quickly as the metal spoon, all right? That's because the metal spoon is made out of a metal which has a lower specific heat than wood does, all right? So given that it has a lower specific heat, that means that it does not take as long for the metal to heat up. It doesn't take as long for the heat to travel gram by gram through the metal and to heat it up by 1 degree Celsius, 1 more degree Celsius, more and more and more until it gets hot enough to hurt when you hold it. Okay? So that's specific heat. We've been talking about specific heat in terms of grams and in terms of degrees Celsius just to make it a little bit easier for you to work with. But from now on, we will be talking about specific heat in terms of kilograms and in terms of kelvins. That's a more scientifically accepted way of referring to units. So we'll say that specific heat refers to the amount of energy that it takes to raise 1 kilogram of substance by 1 Kelvin. Kelvin is just another temperature scale that we use. There is a comparison between Kelvin and Celsius. They both measure temperature. They just do it on a different scale. They use different numbers and things like that. But all you really have to know for this portion of the class is that Kelvin represents temperature in this case. So the correct statement for a specific heat, the specific heat of a substance is the amount of energy that it takes to heat 1 kilogram of that substance by 1 Kelvin. And I repeat this in the next few slides, so take a look at the next few slides and you'll see the text to what I'm saying. All right, go ahead and hit the button for the next slide now.